Let t be equal to the integral from negative pi over 2 to pi over 2 of cos x dx times the integral from pi to 2 pi of sine x dx times the integral from 0 to pi over 8 of 1 over cosine of 3x dx. Which of the following is true? T is equal to 0, t is less than 0, greater than 0, or not defined. Okay, so I want to start by working out the sign, positive or negative of a whole bunch of these quantities. The first integral is positive. The second integral is negative. So the answer here is the second integral negative? Yeah, the second integral is negative. So the answer here is going to be determined by the sign of that third integral, in particular whether it is even defined or not. So maybe it'll help to consider what the function cosine of 3x looks like. Well, so where does cosine change sign? Cosine changes sign at, if I put a pi over 2 here, then that's more or less what cosine looks like. But we are concerned with cosine of 3x, so this would actually sort of happen at pi over 6, but this term is only integrating up to pi over 8. And we're considering the reciprocal, although that doesn't matter. That would only matter if, if we actually integrated all the way to pi over 6, then the 1 over cosine of pi over 6 could end up mattering. Okay, so let's write down what we've figured out here. Okay, so yeah, this last integral is positive, and so multiplying these all together, we're going to get something that is negative. So t less than 0 is my answer in this one, which is option B. Yeah, nothing too special here. We can evaluate the first two integrals quite easily if we wanted to. If you know what the area under each of the humps of a standard trig function is. The third one, I wouldn't care on how to evaluate this because, we're just asked for the sign of everything here. And being sort of bounded away from a potential problem point of this function allows us to conclude really easily, yes, it's defined, and we can see from the shape of the function that it's definitely positive. Not much more to say about this one, but if I think of anything, I'll put it down in the description. Thanks for watching.